Hello AAT, we're on section 2.8. This is the last section in chapter 2. We are solving quadratic equations. It should be very familiar from Algebra 1 and Algebra 2. The solutions to a quadratic equation are where it is equal to 0. When we're solving a quadratic, which means something in the form ax squared plus bx plus c, we always try to factor it first, but if it doesn't factor, we're going to need to use this quadratic formula. When the quadratic equation equals 0, you can find roots or sometimes zeros wherever x would solve this and make it true. For a quadratic equation, there are usually two solutions, shown at right. So your solutions, your zeros, are also called the x-intercepts. So no, roots, zeros, x-intercepts are all the same thing, but roots can be imaginary numbers. And of course, x-intercepts and zeros can't be imaginary because they wouldn't show up on the graph. So one can find the solutions by either graphing the function, and you can see them, or factoring it. Of course, you want to do that because that'd be easier, or using the quadratic formula. There's also a fourth one that you did in Algebra 2, which is completing the square, but we will not be doing that right here. We did do that some with parabolas earlier. So here's the quadratic formula. I know you do it. You do know it. Feel free to sing the song, opposite b plus 2 minus square root b squared minus 4ac all over 2a. The radicand in here is called the discriminant, the b squared minus 4ac part. The discriminant tells you the nature of the roots, and the value of that is sometimes you want to know ahead of time, am I going to have two x-intercepts? Or maybe I'm going to only have one x-intercept, like this. Or maybe I'll have no x-intercept and my parabola won't hit the x-axis at all. If you have two x-intercepts, that's going to be, you're going to have two real zeros. If you only have one real zero, and if it's floating up here like this, or maybe the parabola is down below like that, and didn't hit the x-axis, then you had imaginary roots. So if you find b squared minus 4ac and it's positive, you're going to have two distinct, meaning different, real roots or zeros like this. And that's because, just think about it. If you have negative b plus or minus, let's say you have square root of 10 over 3 that comes out, this is two answers, and they're two real numbers. They're not imaginary, so you end up with 2 because you got the plus and the minus, two different x-intercepts. If the b squared minus 4ac is 0, well, if you had negative 2 plus or minus square root of 0 over 3, well, that's just going to be negative 2/3. You would just only have one root, and it's called a double root because it actually, if you were to factor the equation, it would occur twice. It'd be like x minus 2, x minus 2. And so you have that just one x-intercept as opposed to 2. But if it's 0, like if you have negative 2 plus or minus the square root of negative 10 over 3, that's going to give your imaginary. And there's two imaginary roots because you have the plus and minus, and it's a negative square root. And when that happens, then you're not going to hit the x-axis at all. So first we're going to try to find the discriminant of this thing and describe the nature of the roots of the equation, then we're going to solve it. Okay, so the discriminant, make sure you're showing this is b squared minus 4ac. And so a is the number that comes in front of the x squared, which here is 1. Your b is the negative 4. And your c is the 15. So b squared would be negative 4 squared. Make sure you keep the negative with it. Minus 4, a is 1, c is 15. And if I simplify that, negative 4 times negative 4 is positive 16, minus 4 times 15 is negative 60, which would be negative 44. So this is less than 0, which means there are no real roots meaning 2 imaginary roots. You need to tell us that. Okay, so then if we continue to solve for the roots, well, let's do the whole quadratic formula. So starts with the opposite of b. Well, the opposite of b is 4, because it was -4, so 4 plus or minus square root of b squared minus 4ac. Well, I already found that's -44, all over 2a, and a is 1. Sometimes the hardest part is just simplifying this, but that's important. So this is 4 plus square root of -44 over 2, and 4 minus square root of -44 over 2. Should know how to simplify square roots. If there's a negative, you pull it out and it becomes an I. 44 is 4 times 11, so I can pull out the square root of 4 is 2. And don't forget that 2 on the bottom. And of course, we'd have the same thing with the negative version. And then we can simplify. I'm sorry, that was supposed to be a 4. But only if this 2 will go into every single term. So be careful of that. 2 will go into 4 2 times. 2 will go into 2 1 time. So 2, make sure it's dividing into both things. If it only divides into 1, you can't simplify. So this is 2 plus I root 11 and 2 minus I root 11. Those are your 2 solutions. Those are your 2 roots, 2 imaginary roots. And you are welcome to write it as plus or minus, but sometimes it's easier to separate them. Okay, so let's solve this. So we're going to go right to the quadratic formula. We could find the discriminant first, but let's do the whole thing out. So our A is 6, our B is 1, and our C is 2. So opposite B plus or minus square root of b squared minus 4ac over 2a is what we're doing. So opposite b would be -1 plus or minus square root of b squared would be 1 minus 4 times a is 6 times c is 2. Take your time. All over 2 times 6, 2a. Okay, so if we simplify that, we get -1 plus or minus, so 4 times 12, or 4 times 2 times 6, that'd be, let's see, 4 times 12, 48, and so we have 1 minus 48, so that's the square root of -47. So again, we're going to have some imaginary stuff going on here. Over 2 times 6 is 12. Got to pull out that I, so it's -1 plus or minus I root 47 over 12. Cannot simplify 47, so it stays like that. All right, moving on. Describe the discriminant of the equation represented in the graph. So what do we know about a discriminant if there's only one x-intercept? We know that that discriminant, b squared minus 4ac, is equal to 0. Always true if you have only one root. If you have no x-intercepts, here we have 1, your b squared minus 4ac was giving you imaginary numbers, so it was negative or less than 0. And if you have two x-intercepts, your b squared minus 4ac would have been positive. Okay, solve each equation. Okay, so I would pause the video here, try to do A and B, and make sure you can use the quadratic formula and simplify and come out with the right answer, and then we'll look at C and D. Okay, let's see how you did. So on this first one, A is 1, B is 8, C is -20. And be careful when you have this negative and negative here. Well, first of all, don't forget it has to equal 0 to use this zero product property. So you needed to bring that -20 over first. Your B is not on the equal side. It has to be set equal to 0 before you find, C, what C is. So when we simplify all this mess, we get negative 8 plus or minus square root of 64 plus 80 over 2, which is negative 8 plus or minus square root of 144 over 2. And that gives you a really nice rational number. Negative 8 plus 12 over 2. And negative 8 minus 12 over 2. Negative 8 plus 12 over 2 is 4 over 2, which is just 2. And negative 8 minus 12 over 2 is negative 20 over 2, which is negative 10. So these are your answers, which are your x-intercepts. Now, if it just says solve the equation, it doesn't say you have to use quadratic formula. You could always look and see if you can factor. If your numbers came out to be nice like this, even if they came out to be fractions, not imaginary, and it wasn't a square root in the answer, it could have been factored. This is x minus 2 and x plus 10, which would have been much easier to solve. Use your zero product property, and x would be negative 10, x equals 2, setting them both equal to 0. So always look and see if you can factor first, because of course that's easier. But the quadratic formula always works as well. So here we could have factored. We'd have 2a minus 3 and a plus 7. And if you'd factored, you'd get 3 halves and negative 7. But you get the same thing if you got the quadratic formula. So if you didn't get this with the quadratic formula, you want to go back and look and see what you did wrong. Okay, so for C, I'm thinking I can factor that. That's m and m, two numbers that multiply to be 36 and add to be 12. I'm thinking 6 and 6. Set them equal to 0, and I'm going to get m equals negative 6. So just for the fun of it, let's see what would have happened if we did the quadratic formula. Opposite b plus or minus square root of b squared is 144 minus 4, a is 1, and c is 36, all over 2a. Well, 4 times 36 is 144. So 144 minus 144 is just 0 in that root. And so all that root mess is gone. So all I have is negative 12 over 2. Plus or minus is irrelevant now, and that does give me negative 6. So I could totally have done it that way. Okay, this one I can see does not factor. If I try t and t, there's no two numbers that multiply to be 13 that would add to be negative 6. So it does not factor. And if it's not factorable, well, that means I'm either going to have an imaginary roots, or perhaps I'm just going to have a square root. So opposite b plus or minus square root of b squared, which would be 36, minus 4ac. All over 2a. Take your time doing this. So this is 6 plus or minus square root of 36. So 4 times 1 is 4. 4 times 13 is 52. I'm subtracting those. All over 2 times 1 is 2. So it looks like I'm going to get some imaginary solutions here. So 6 plus or minus 36 minus 52. Let's see. 52 minus 36 will be 12. Make that a 4. That's a 16. Negative 16. It's the square root of negative 16 over 2. Well, the square root of negative 16, I can pull the I out, and the square root of 16 is 4. So that's just 6 plus or minus 4i over 2. Don't forget to simplify. If that 2 will go into both numbers, has to go into both, 2 will go into 6 3 times. So when I subtracted 36 minus 52, I got negative 16. 16 is a perfect square, so the square root of 16 is 4, but since it was negative, it was I. Make sure this 2 can go into both numbers before you can simplify. 2 will go into 6 3 times, 2 will go into 4 2 times, but you still have that plus or minus there. All right, so this one, make sure that everything equals 0 before you start. So p squared, also make sure that constant term, the p, is in the middle, plus 5 equals 0. So let's see if maybe this will factor. It looks like it might be factorable. So p and p. I need two things that multiply to be 5 that add to be 6. So I'm thinking 5 and 1, and both of them are negative. So I get p equals 5 and p equals 1. So if you can factor it, go for it. If not, do the quadratic formula. Okay, set this equal to 0. So we're going to subtract the r for r. We're going to add the 10. Make sure the constant terms last, the linear terms in the middle. And will that factor? Don't think so. So negative b plus or minus square root of b squared, which would be 16, minus 4 times a times c, all over 2a. So this is 4 plus or minus square root of 16 minus 40. 16 minus 40 would be what? Negative 24 over 2. Okay, so I can definitely pull an I out. 4 plus or minus. And I'm going to pull an I out. And let's think. If you're not sure how to simplify it, 24, remember when we learned to simplify square roots, is 4 times 6. 4 is 2 times 2. 6 is 3 times 2. Pull out anything that's a perfect square. So square root of 24 is 2 root, these stay in, 6. 3 times 2 stays inside. So 2 root 6, the 2's coming out with the I, the root 6 is staying in. Okay, that 2 will go into everything. Don't go into the root. You can't have a no root go in the house with the root. That doesn't work. 2 will go into 4 2 times. 2 will go into this 2 1 time. So you just have the I and the root 6. And there's your answers, your 2 imaginary roots. All right, thank you. Make sure you work hard and make sure you can do them on your own.